Afternoon, whichever it may be. Um, this is a walkthrough, a summary of where we are and where we're going. Um, this is Thursday, I guess it's the 9th. Okay. So just to bring you up to date, I did receive many of the polar coordinate and de Moivre theorem problem set take home. I looked at them and I created a spreadsheet which I posted on Blackboard with the anonymous results. And that covers material in chapters 10, sections 1, 2, and 3. Chapter 10, section 4 and 5 is on vectors. And it's a little more complicated. So for that reason, what I did is the vector problem set take home, instead of having it due on Monday the 13th, and this may be a mistake on my part, I'm having it due on Wednesday the 15th. So that may be a mistake. We'll see. So at any rate, just do a little walkthrough on that. The topic of vectors was covered in classes 16 and 17. That will be Monday, April 6th and Wednesday, April 8th. Sections 10.4 and 10.5. So the vector operations problem set take home, which you should be doing. Please don't wait till the last minute for these things. It's just too much, okay? Um, they very, very closely follow the problems and examples that I worked out on vector operations 1 and vector operations 2 videos. Okay, so you have copies of this stuff in PDF format. So even if you have difficulty, it shouldn't be too much to pause the video and take a look at the printed PDF explanations. Okay, so I'll just do a quick walkthrough of the vector operations problem set take home. And I'm just going to say that every single problem there is an analogous problem worked out in the video presentations and on the vector operations 1 and vector operations 2 PDF files. So there's nothing on there really that you have to be concerned about. If you just look at the videos and you replay them and you look at the examples that I do, then you should have sufficient knowledge in order to do them. I'll just point out to you that the angle and the dot product are pretty much done in the second series, vector operations 2, whereas the basics of vectors is covered in vector operations 1. Questions 13, 14, and 15 on the vector operations problem set take home are very, very, very similar to the graphing examples that are done on in the first set of videos. Okay, so if you take a look at that stuff, it should be pretty clear. I'm asking you to draw pictures, but on the video I do it by pictures, and then I do it by vector component by component computation. So I did it both ways in the answer sheet, which you'll see after everybody hands these things in. But what I'm asking for, 13, 14, and 15, are the labeled diagrams, and it's really not difficult. Okay, so the front page pretty much, is just computational. Question 11, of course, you need to know material from the dot product, because that covers how you find the angle between two vectors. So that would be in the vector operation 2 videos. And question 12, of course, the projection, which is just a shadow in the line of another vector. The book doesn't really describe it in terms of a shadow. That's how I usually think of it. I think that's a good way of understanding it. It's not an easy concept, but you can do it. So Question 7 and 11 then are covered when we talk about angles in vector operations 2. And question 12, which is a projection, also is in the second set of videos. Okay, 16, 17, 18, second set of videos. You're looking for cosine theta, and you know if cosine theta is a 1, then your angle is theta is 0, and therefore the vectors are parallel. And you know if cosine theta is 0, then the angle would be 90, which means the vectors are orthogonal. And orthogonal is just a fancy name for perpendicular. So orthogonal is useful for vectors. And one of them there, of course, is a neither, not orthogonal, not parallel. So you'd have to compute the angle. And that's the same method that you used in question 11. So, these are things, if you follow along with the videos and if you print out or even you look and download and look at the associated PDF files, you should not have an issue. Question 19 is the most difficult. I mean, if you look at the end of vector operations 2 at the videos, I do the theory, couple slides, and then I do 2 fully worked out problems which are similar to what I'm asking you to do in 19. So if you follow the pattern and what we did, that should not be an issue. Okay, I'm going to start putting up material for classes 18 and 19, which is Monday, April 13th and Wednesday, April 15th. And this will be on conic sections, so we're going in the order of the textbook. We'll start chapter 11. And the first, I guess, class 18, which is that Monday, we'll try to do section 11.1, which is a general overview of the conic sections. That's circles, ellipses, parabolas, and hyperbolas. And also in class 18, I'm going to try and work on parabolas with you. Now, there are 2 classwork worksheets on Blackboard. One of them is called, I think, a matching column, when you match the equation of the parabola with the actual picture. And there's a second one where you get the picture, you have to write the equations, which I'll do those on combination of mostly, I guess, on the whiteboard, okay? And then we're going to do some examples where you get the equation, you have to put it in standard form for a parabola, that is, completing the square. And that's the kind of thing which we will find in the parabola problem set take home, and that's already up there. That I'm going to make due Friday, April 17th. Okay, so you have a lot of time for that. Most of you are going to do very, very well on that. The way I set that up, I gave you a nice answer blank, and you just put and you show the work, and then from the work, just like I do on the whiteboard, which I haven't put up yet, but I will. Just put the answers in the boxes and you make a sketch. It's going to work out very easily. Okay. Doing parabolas is fairly easy. Ellipses a little tougher. I'll try and cover that on class 19, which is April 15th, and hyperbolas also a little bit, detailed and tricky. I'll do that as well. And I'm not sure if I'm going to cover translation of axes, or rotation of axes, rather. I'm pretty sure I will, but that will be later on. So please try and keep up. I know the times are difficult, and it's not easy. It's certainly not easy for me doing all these presentations. And these videos, and I know it's not easy for you as well. And again, the reason why I chose to do the YouTube path is because you don't have to be available during what would have traditionally been our class time, 6 to 7:50 on Monday and Wednesdays. You can view it at any time is convenient for you. You can review it. You can go back, you can pause it. So I think that makes it much more flexible. Okay, so I'm hoping that this works out for you. And of course, if you have issues, you can contact me via email. I'll try to do my best to help you out with that. But as I said, it's a difficult time for everyone, and you certainly want to do your best. You put in the time, and you take these things step by step. And I'm not going to try and trick you. You just try and go by what we're doing, and hopefully things should work out for you. Okay? So be well, and I'm going to post some videos on conic sections and parabolas probably in the next day or so. Okay? So be well, and good luck with the vectors. Vectors are interesting. Bye-bye.